In this recording, we're going to look at how to solve quadratic equations that have complex solutions. That means the solutions could have I in the answer. Go ahead and take time to write down the heading and the directions and the example we're going to solve, and then play the recording when you're ready. Okay, so hopefully you took time to write down the directions and such. We're going to solve this with the quadratic formula because you can't solve it by factoring. Already the directions are telling me that the answer is going to be in simplest a plus bi form. That's a pretty good indication that my roots are going to be imaginary. No way to solve that by factoring. You could solve it by doing the completing the square method, but in this case I'm going to use the quadratic formula. Okay, so first thing I'm going to do with the quadratic formula is what I always do, identify the value of the discriminant. So let's say what a, b, and c are. A is 1, b is -4, c is 29. Okay? Why don't you work out, you've had lots of practice with the discriminant, why don't you figure out what the discriminant is and then play the recording when you've got it. Okay, so hopefully you took the time to figure out the value of the discriminant. So I've got here a -4. I'm going to square that. -4 times 1 times 29. All right? So that looks like a 16. That looks like, well, I got to think about that. That would be 120 take away 4. I think it's 116. I think that's going to work out to a -100, which is about what I thought it would be. I thought it was going to be a negative. Tell me why I thought it was going to be a negative. Hopefully you're shouting at me through the whatever device you're watching this on and saying, of course it's a negative, Mr. Clinton, because the answers are going to have I in them. And the only way for I to show up in the answer is if you square root a negative. And we always square root the discriminant, right? So now let's get right into our quadratic formula. We've got x equals -b. So -4 makes a 4. Plus or minus the square root of b squared minus 4ac, all over 2a. 2 times 1. In blue here, I'm going to put the b squared minus 4ac, the -100. Okay? So that just drops right in place of the discriminant in the quadratic formula. Conveniently enough, we can break down the square root of -100 using I. So I'm going to write it as 4 plus or minus 10i. All over 2. Well, each term is divisible by 2, so I'm going to say my final answer is 2 plus or minus 5i. That's the solution set right there. And it says check using your calculator. So if you happen to have access to a graphing calculator, let's check it. So I'm going to store the answer by typing in 2 plus 5i. Now you could have done 2 minus 5i. You remember how imaginary solutions, complex solutions, always come in conjugate pairs. So if I check 2 plus 5i, that pretty much guarantees 2 minus 5i is going to work as well. So I get that. I press the store button, which is right here, above on. So stow x. Now type in the equation. X squared minus 4x plus 29. And it's substituting in place of my x, it's substituting the expression 2 plus 5i. I hit enter, and I get a 0. And that's what I hoped it would be, because I was trying to find the value of x that would make the equation 0. It checks beautifully. All right, in this second and final example, I'd like you to get as far as you can solving this quadratic using the quadratic formula, and then play the recording when you are stuck or you've got a final answer. Okay, so hopefully you took time to work this out or get at least as far as you can. So I'm going to work out A, B, and C first. Of course, I can't identify them until I've got an equals 0. So I'm going to say 4n squared minus 8n, kind of a sloppy 8, plus 9 equals 0. Now I'm able to identify that A is 4, that B is -8, and that C is +9. I can then go to the discriminant portion of the quadratic formula, the b squared minus 4ac. Work that out. So you have a -8. You got to parenthesize that -8. Please put that in parentheses when you put that into your calculator. Minus 4 times 4 times 9. When you do that math, it comes out to be negative 80. Okay, because it's 64 minus 144 is negative 80. Now we can jump into our quadratic formula. So we've got x equals negative b, so positive 8, plus or minus the square root of the discriminant, I'm going to color code it here, negative 80, all over 2a, which is 2 times 4, 8. Simplifying this, 8 plus or minus, well, because it's a negative under here, I got to take the I out first. Negative square root of 80, all over 8. Now, square root of 80, you should remember, can be broken down. I see a perfect square that goes into it. And you might say 4 goes into it, and you'd be right. But the largest perfect square that goes into it is 16. So it'd be square root of 16, square root of 5, and that becomes 4 square root of 5. So all this becomes 8 plus or minus 4i square root 5. Remember, that's the convention. Put the rational part, the imaginary unit, and the irrational part in that order. All over 8. That's our answer. I see a little bit of simplifying that can be done, right? So I see that all the terms can be divisible by 4. So I can divide 8 by 4, I get 2. 4i root 5 by 4, I get I root 5. And then divide 8 by 4 and you get 2. That's our final answer. Thanks for watching.